Okay, guys, good afternoon. So today I'm just trying to understand that if we open any websites and if we see that there is a secure button or the lock is there, then what is the basic concept behind it? For example, if I open super value, let's take a very basic one, and I can see that in this top left corner there is a uh, lock button is there, and this lock button is taking me that saying that it's a connection is secure. And then if I open more, it say that okay, yeah, it's verified by DG cert. Then we just let's understand that how basically this all are happening and what is this security all about. So as probably we already know that over the internet is a public, and over the internet whenever we do some information sharing, it should be secure and safe. Why secure? Because anybody like a man in the middle can take your information or can grab your information and can see what's going on. So the best solution or the first solution we take, we do the encryption. So if we know, if suppose I open a website called supervalue.ai, so we all know that the basic call goes to the server or the web server where the SuperValue website host, and then server send the information to our browser. So this whole process, if we wanted to do in encrypted way so that no man in the middle can understand what data is transferred between my browser and the SuperValue's web server, then this whole communication is secured by called a terms called SSL. This is socket secure layer, which can say. And how this socket secure layer works, that's I wanted to show here very quickly. And for that, I just prepare a very small one. Where it gone? Yeah, this one. You can see my screen. So this is just a basic how the SSL work. I'm not going to detail what is SSL and how the what is the HTTPS full form and all those things. Everybody know it. So let's start saying that whenever we want to encrypt our data, for example, if you want to say that I want to send a browser, super value server want to send information to my browser, he want to do it in a secure way. So he used a concept called encryption. So the encryption usually popular is two kind of encryption. One is symmetric, another one is asymmetric. So what happened to the symmetric? Both the browser as well as the web server agree on some key, which is called a symmetric, which is called a shared key. And whenever a sender, like for example, here is a Bob, here I take an Alice. So if Bob want to send some information in encrypted form, he has that shared key, which is only shared between the receiver and sender. In this case, it's a Bob and Alice. In our case, it's SuperValue, my browser and the SuperValue server. So this shared key used to encrypt this plain text, what I'm going to send or what the Bob is going to send to Alice. And then the same key can be used by the Alice to decrypt the information and can see it, so that nobody in the middle can able to see this information, which is fine, which is very secure, and there is no harm in that. But the main problem is that how this secret key can be shared with each other. Means either is Bob can go personally and meet the Alice and take Alice this secure shared key and use this key for the future, which is not a feasible solution. So that is the big problem of this symmetric or shared key encryption or symmetric encryption. There is another called encryption technique, and in this symmetric encryption, the algorithm that we use is called SAES, which is a very standard advanced encryption standard. The other encryption technique, which is called a asymmetric one, which is very popular and most of the websites or browser and server are use it even now also, which is called a asymmetric encryption, where two kind of keys there. One is called public key, one is called private key. Now, what happened again? Let's take a sender Bob and receptionist Alice. So what happened that first of all, both exchange each other public key. For example, if Alice wanted to share something to the Bob, it said that if Bob shared something to Alice, Bob asking the public key of the Alice. So Alice shared a public key. So you can see that public key of Alice is now with the Bob, and Bob sent a plain text, encrypt the plain text with the Alice public key. Now it returns a cipher data, which is encrypted data, and send it over to the Alice. Then Alice can open that information by her own private key, which is mathematically related to the public key. That means if any public key encrypted the data, then the corresponding private key, which is tightly coupled with the public key, can only encrypt that or only decrypt that information which was encrypted by the public key. So it's a mathematical where two mathematical keys are derived, which are somehow interrelated, but it's never be reversible. Like if you have public key, we can't get private key. If we have a private key, we may get public key, but the vice versa is never true. So that means if Alice public key is used to encrypt the data, then only Alice private key will be used for decrypting. That's the whole concept of asymmetry. Now, again, if let's say that they both want to do this conversation with the help of asymmetric one, public private. But again, the problem will is still there. Why? Because if both sharing the key, for example, let's understand with this way, that suppose Alice wanted to talk to, or Alice wanted to have some information. So Alice share his public key to the Bob, but while it's sharing over the internet. And in between, mad in middle, will take the Alice public key, and rather than sending Alice public key to the Rob, it send its own public key to the Bob. So Bob know that, okay, I got the Alice public key, but actually it's not the Alice public key, it's a Ron public key, which is a mad in middle. And then it sent the information, again, that considering that this is going to Alice, but in middle, this middleman read the information, change the information, and again, since it has the Alice public key, it again send it back to the Alice and with her own public key, but actually it changed the content. So for Alice, it looks like that it's reading the message sent by Bob, but actually this message is not sent by Bob, it's sent by the man in middle, which is this guy. I hope this is clear. Yeah. So the same thing happened. The same thing happened with vice versa. Yeah. So and this is the overall conversation which was happening. So if you understand that the problem is not the encryption and description, the problem is that how Alice know that the public key what it receiving is actually the Bob, not the middleman one. That's the problem. Encryption description is fine, it's working perfectly, but the only problem is that how Alice know that the public key that she is getting is actually belongs to Bob and vice versa. So that's the rescue of this problem where the receiver is not very sure or how the receiver can faith on the public key what he received, that it is actually the sender public key, not any other middleman public key. And that comes the concept of certificates, where the certificates come into the picture. So this is the same picture which I explained here, how the middleman changed the value and then send its own public key to change the value. He sent at the result he sent hey, but actually in the Alice received a bye because middleman changed by this public key swapping. So solution is that before going to the solution, let's understand very few concept, which is very simple one. One is called a root certificate, intermediate certificate, server and client. So whenever we talk about the certificate, there are two new terms are introduced, or we have to introduce two new terms to understand whole concept. Server means web server, we already knew. In the case of it's a super value web server. Client means our browser, which actually open the website. Root certificate authority is a government or any public institution which have the right or have a authority to issue the certificate. Intermediate CA is another form which is work same like the root one, but it's called intermediate certificate authority. And the major difference between these two, that root certificate authority works offline and intermediate certificate authority works online. Now, when I say offline, online, what it means that root certificate authority never provide any kind of certificate over the wire or by internet or by mail. Whenever we want to get any certificate from root certificate authority, we have to personally visit or by mail or by M-Post, or you can say or by Indian Post Office, anything, to get the conversation or to get the certificate. Means it is not available on the internet, you can say. this certificate, or this work totally offline. Why? I will explain you. Intermediate certificate authority is the one which actually issuing the certificate to the servers. For example, in our case, it whenever the super value want to get its certificate, it contact to the intermediate certificate authority, which takes the information of this server like super value, wherever it belongs, whether he had a correct domain name, whether he is following all those security norms, encrypt and everything. And then based on this super value information, this intermediate security CA will issue a SSL certificate to the super value. So if I say what it issue a SSL certificate to, let's say, super value in our case. Now, what happened and then what is the role of this one? Let's understand. Now, this root certificate authority is responsible to authenticate intermediate certificate authority, and then intermediate certificate authority is responsible for providing the SSL certificate to all the servers or service providers which are available over the internet. How that works, let's understand. For example, if I say that this is my browser and this is the super value server, and somehow here it's a CA. When I say CA, it's intermediate one. And if I say root, so means root authority. Now everybody know that public key and private key, so I'm not repeating. So what happened when the browser request, when the browser hit the super value website, this super value server returns back. It returns two information. One it returns is SSL certificate of its own, which have information about super value public info, its public key, which our browser will use to communicate with super value server, as well as it will have second thing, which is the CA certificate. This CA certificate contains, yes, I am authorizing super value, and for me it is safe. It is authenticated and safe, whatever it's auth and safe. Now, if that is the case, if browser request open the website and the super value server return these two information, of course, this also can be altered very easily over the wire. If I send this info, if a super value server sending these two files, it can be altered or man in middle can hack it. Now, but there is a hack in between. What happened? This two information, for example, this two piece of information, one is SSL certificate of super value, as well as with the public key of super value, as well as the CA certificate. This both are already encrypted. Now, here comes the picture of how it already encrypted. The SSL certificate of super value is encrypted by private key of CA. Got it? Whereas the CA certificate is encrypted by private key of root certificate, root authority, root CA. Now let's understand. Suppose a browser requested to super value return two things. SSL certificate. This one is encrypted by private key of CA certificate, and then CA certificate is another piece of information which are received by the server browser, and this CA certificate is encrypted by a root private key. That means both the information SSL certificate as well as CA certificate both are encrypted, and both are encrypted by a private key, but the only difference is that this SSL certificate is encrypted by CA certificate, CA authority private key, whereas CA certificate is encrypted by the root authority private key. Now, once it reaches to the browser.
Vikas, one question.
Yeah.
On browser and interaction between browser super value and CA.
Mhm.
So this SSL certificate is, I mean, it is this SSL certificate by generated by whom, like super value or CA?
CA, a super value already communicated to CA and have this certificate with its on its browser. When it's sending to the browser, when it's super value server already have this SSL certificate and CA certificate with its own place. Whenever browser is going to access the super value website, to make it SSL or make it authenticate or validate, super value server will return back the browser two things: SSL certificate and this CA certificate. That means this two information is already kept by the super value server. And when the browser requests, this two value will return to the browser.
Oh, I thought this SSL certificate is actually encrypted by the private key of
That's
super
correct.
value.
That's correct. No, but there is a catch. Both are sent by the super value server, but the SSL certificate which are transferred from super value server to browser is encrypted by a private key of CA, and the CA certificate which is sending by the super value server is encrypted by the root CA private key.
But how the super value server get the access of private key of CA?
Via CA certificate. So once this super value is going to register its domain and get the SSL certificate to CA authenticate and validate all the information offline. And then once it satisfies that the super value website is following all the norms and conditions, it gives the certificate, SSL certificate to the super value, which is having the expiry date, If you see the certificate, it mentioned this expiry date. So if I am a super value, I go to the personally to the CA certificate office and to fulfill all the formality, get the certificate, which is a valid for 1 year or something. Got it?
Yeah, generally it is 1 year.
Yeah.
Earlier, I think it used to be 3 years, and now they have reduced it to 1 year for security reasons.
Yeah, but here the main thing are to understand that this SSL will encrypted by private key of CA and the CA certificate encrypted by the private key of root. Now, how the root involved, that's we understood. Now, up to now is clear. Can I move? Just thumbs up. Okay,
yes.
Perfect. Okay, so now what happened when both the information to the browser and the browser need to know that how if he's faithing on the super value, whether the super value is the right thing or not. So these two information, first of all, this CA certificate, which is encrypted by the private key of root. So of course, when it reaches to the browser needs to see the certificate, CA certificate first. To see the CA certificate, it needs a private key public key of root authority, because this CA certificate is encrypted by the private key of root, correct? So that means somehow the browser should have the root as a public key, then only it can able to see the value what is stored inside the CA certificate, or how it know that CA certificate which is encrypted by the private key, he cannot decrypt it. So to that, if we know, and we already know that root authority always work offline. So if we know how this happened, everybody know that whenever the operating systems comes, all the root certificate private key automatically provided by our operating system. To understand this, we can see very easily. If you can see here, I can search here certificate. You can see my run command. What I'm doing here on the run.
Yes.
So if I open this run, and if I see here you can see this screen trusted root certificate. If I open this, you can see here lots of certificates are there. This is the list of all the root certificate authority available on the globe or all over the globe, which works offline. So that means they always issue the certificate offline, but operating system provides this the public key of all these root CAs to our system with Windows operating system. So now it will be easy to understand for us that whenever the browser receives CA certificate as well as SSL, first of all, it decrypt the CA certificate with using the public key of root so that it can check, okay, since the subscription, say it decrypted, it received the value. What it found? It found that CA certificate had the public key of CA authority. Now, that means the CA authority is decrypted and browser knows about the CA authority. Now, the next come to SSL certificate. SSL certificate is encrypted by the private key of the CA. Now the browser have the public key of CA just because from this CA certificate. So it can easily open the SSL certificate, which was encrypted by the private key of CA intermediate authority by using its public key. So by that way, SSL certificate is open, and since it was opened by the CA certificate public key and CA certificate opened by the private public key of root authority, which is already in the browser or in our window application. So this two-way of, or you can say two-stage of confidence building is there. And by this way, it actually get the super value public key, and that public key is used by the browser whenever it's going to send any information to the server. So what I did here, maybe it's not 100% clear. So let's quickly see what I written here, that how that basically works. So it's written here, if you see, server send two information, intermediate certificate authority certificate and server SSL certificate. When I say server SSL certificate, means super value SSL certificate as well as the CA. SSL certificate is digitally signed by the intermediate certificate authority private key, which I already explained, and intermediate CA certificate is signed by the root certificate private key. Now, server does not send root certificate. Why? Because operating system already provided us the root one. So the root private key, public key we already have. Now, with the help of, when we use the intermediate, with the use of root public key, we first open the intermediate certificate, and with the help of intermediate certificate, we get the public key of intermediate certificate that will be used to open this SSL certificate. So this is a two-phase of step. And why the two-phase? Why we want to do a two-phase? We can directly get the root certificate and do this encryption and description, because to make the things more secure, that's what is mentioned here. To make the more secure, we are relying on the two layer of security rather than the one layer. And that's what I mentioned here, that because this root certificate authority always kept offline, and they always kept this public key offline, because of the fear that if the private key of the root authority is somehow compromised, then mostly the few millions of the computer over the internet will be sacrificed. Yeah, because that private key is the key. So that's how it works. The whole things which work. If you see here, different type of certificate. Again, to repeat, this is the super value certificate on the top. It needs it to verified by the intermediate certificate, and this intermediate certificate is verified by the root certificate. And when it's sent over the wire, so the root certificate private key will be used to encrypt this intermediate certificate, and then intermediate private key will be used to secure this certificate, which is as the form of SSL. And that's how the SSL work. And this is, once this happen, once the browser get this information or get this information, okay, that now I have a public key of the super value, then browser send a pre-master key, which is called a pre-master key, to the super value server, and then super value server got the pre-master public key, and with the help they created a secret key, and that secret key will be used for future session or for future communication as a key as a shared key for symmetric communication. And that's why This whole process up to here is called SSL handshake. I hope it's clear. Any doubt, we can take it.
I'm a bit confused about the offline
Yeah.
thing,
Yeah. No problem. Please.
So, so how, I mean, see, you mentioned that the root certificate or the root authority private key is offline, right? It is provided, let me confirm, it is provided through the operating systems, right?
Correct.
Okay. So when you say offline, it means that it is provided through the operating systems mostly.
No. Operating system only have public key, not the private key.
Okay.
I'm saying
So how,
that I'm telling that the private, I can explain quickly again. So in this figure, which is showing here, root certificate used is private key to encrypt this intermediate certificate. Got it? This point is clear. Now, this root certificate never share its private key to anybody. Now, this intermediate certificate, which is private key encrypted one, who can open it? Of course, only public key of the root certificate can open this intermediate certificate, which is provided by the operating system. So this private key never shared with anybody. It is only used by the root certificate authority when this intermediate domain or intermediate firms go to the root certificate office, submit a detail asking that, can you please encrypt my certificate? Then the root certificate maybe open its treasure and open the private key. I'm just explaining, and then put a encrypt the date, certificate and provide to the intermediate certificate authority. Look, this is your certificate. Now I encrypted with my private key. And now only my public key, which is with the operating system, can only decrypt it. Nobody else can do it because I encrypted it with using my private key, which I never share, or even I don't share over the internet. That is in my pocket only, and I'm offline.
I guess it comes with the operating system and the browsers too. The browsers also has the public key of these certificates.
Yeah, of course. So that's so via.
Yeah, and I guess browsers must have access to the OS certificate key store.
Of course. So when the OS has this information, browser is used that public key of root certificate to decrypt intermediate certificate. And once it decrypt the intermediate certificate, it get exposure of the public key of intermediate certificate. And since the SSL is encrypted by the CA private key, the public key which the browser got from the intermediate certificate can able to decrypt the SSL certificate, which having the information of, let's say, super value. That super value public.
Here. Like, let's say we have chain of intermediate CA. Let's say there are I'm an intermediate CA and Nikhil is also intermediate CA and you are root CA, right? And then Nikhil shared this he shared his certificate to me and I shared my certificate to you, right? So how root CA will be able to decrypt my certificate? See, I have generated my certificate based on my public key and private key, right?
Yes, correct.
And you might have the access of my private key to decrypt it, but how will you use your public key to decrypt my certificate?
No, I repeat again. Suppose I am a super value and I wanted to open my website. First of all, I go to CSC, which is intermediate one. And I say that, look, I have submitted all the detail and this is my SSL certificate. This SSL certificate I am keeping with my public key. This certificate have my public key, super value public key. And CA authority said, okay, I verified you are correct. And I am giving you, I am encrypting your SSL certificate, which is having your public key with my private key. Got it? That means CA1 encrypted the super value certificate, SSL certificate, which is private key. Super value is done. He is very happy, and he is going back to his own place. But the CA said, wait. Just not has SSL certificate is not enough. Take my certificate also, and my certificate is encrypted by root private key. So that means when super value come out from the office of CA, what it has is two things. One, its own SSL certificate, which is encrypted by the private key of CA, intermediate one. And that certificate contains its information, is public. Now, SuperValue also have another piece of paper. I'm just saying that to understand, piece of paper, which is a CA certificate. And that CA certificate is encrypted by not CA private key, but root private key. Got you? So now both two information is SuperValue taken. Now SuperValue, when I open the SuperValue website, as a client, I get two things: SSL certificate, which is having the SuperValue public key and SuperValue details, encrypted by a CA private key, and a CA certificate, which is encrypted by the private key of root. Got you?
So this has been given by the root to the intermediate CA.
Exactly. Exactly. Yeah. Now, when I get the two information, first of all, I need to understand, okay, whether the CA authentic or not. How can I believe that CA certificate is correct? So for that, I read that certificate. Okay, who is encrypted it? What is the name of the root? I found out, okay, it's suppose GoDaddy root. So I check operating system. Operating system, do you have the root GoDaddy public key? Operating system give me GoDaddy public key. I apply that public key on the CA certificate. If I can able to decrypt it, then I believe that CA certificate is valid. Why? Because CA certificate is opened by the GoDaddy public key, and that is provided by my own operating system. Now, once I open the CA certificate, I got the CA certificate public key. Now that public key I used for the SSL certificate that is provided by the SuperValue. And I use that public key to encrypt the SSL certificate of SuperValue. I found, okay, yeah, it's open. SuperValue detail is there. And with this SSL certificate of SuperValue, I also have the SuperValue of public key. Now I believe that, okay, now my CA root is also approving it. CA is approving this SSL. That means the CA which is approving this SuperValue is already approved by the root. So I can believe that two phase of trust. One is by root, one is by CA. So I can truly believe that, yeah, SuperValue, whatever is saying is correct. And I can safely use that SuperValue public key to encrypt whatever I want to send to SuperValue. Got it? So that SuperValue private key, when my information goes to SuperValue, SuperValue use its own private key, which he don't share to anybody, decrypt the data which I encrypted by his public key. There is no sharing of private key. Keep in mind, private key is always with the person or authority. Never share the private
but Vikas, see, if I'm SuperValue and I'm requesting SSL certificate from the intermediary certificate authority by creating something called as a CSR, certificate signing request, right?
Yeah.
So at that time, I'll have to share my private key with the intermediate CA.
No. Private key is your own property. You go, you prove that your office belongs to Moxland near the 12 Mulberry apartment or somewhere. You have the permissions, show your papers where paper is correct. Then the CA issue your certificate, SSL certificate, and that certificate is only having SuperValue public key, not private key. SuperValue private public key. And that
which can be decrypted by SuperValue's private key, right?
Yes, and that private key always SuperValue keep. It will not give to anybody. SuperValue will not share.
So for the intermediate CA to issue a certificate, okay, which has a public key and which can be decrypted by SuperValue's own private key, right? Doesn't it have to know some knowledge of SuperValue's private key?
Why I know? I only know that, okay, Nikhil house is there. Nikhil is an authentic person. I can verify his Aadhaar card, his PAN card is valid. I believe on Nikhil. Then I said, okay, this is your, okay, public, share your public key. You share with me the public key. I said, yeah. Based on the Nikhil, he is Nikhil, whose public key is this. And now I am in public key with my private key.
Okay, understood.
And now whoever received the Nikhil public key, believe on me because I am CA and I already encrypted by the root, and can faith on Nikhil. Nikhil is a right person. He's not in a man in middle attack, or he's not a middle.
Right. Yeah. And I guess whenever we do OS system updates, a lot of times we get this Windows security updates and all. At that time, those root CA public certificates are also updated in
Exactly,
our
root CA.
operating
So
system.
if you see that
Right.
it's a lots of like GoDaddy, lots of public. If you go and check yourself, your system must have lots of information. So if I say that all those lists which is there in our registry, all those are root certificate. Yeah. If somehow private key of those authority is leaked, then whole internet is down. You can say is compromised. Whole world is
Yeah,
down.
absolutely. Absolutely. Yeah.
I hope it's clear. If anybody has doubt, we can take it. I can take it.
And I'm sure these root CAs will, there must be a lot of, these root CAs will have a lot of strict security measures in place to guard their own private keys.
Exactly. Actually, everybody should have very safely keep the private key, because private key is the one which
Right.
you should never share.
Right. Right. Yeah. Makes
I
sense.
hope I can able to explain the things.
Yeah,
Other
absolutely.
I guess
It is clear. Yes.
there is no more session needed for PKI now.